Hello, everybody. Happy Friday. Gosh, it's a good thing it's Friday. This week has just gone on for too long. So happy Friday. We are continuing our talk today about graphing, and today we're talking about interpreting graphs. So just to kind of do a little review of yesterday, we talked about the basics of graphing. So when we set up a graph, for example, like how do we make sure we've got all the different items that a graph needs? And we compared kind of the setup of a graph or setting up a graph to kind of like how we build a house, right? So when we build a house, not like I ever have, but from what I've heard and seen, is there's certain things that you do in order, right? So you start with the foundation, you lay the floor down, you get all that mapped out. Then you add the walls, then you start adding your roof. And then the last thing that you do when you're building a house is once it's all built, then you decorate, right? You add your furniture, you move in. Same thing, same technique is good to use when we are building a graph or when we're setting up a graph. So first thing is you write down that label, that x-axis label, kind of like the floor. The y-axis labels, like building a wall, making a good scale, make sure you're using majority of the graph space, adding a roof or adding a title that informs who's ever looking at the graph what the data is showing. And then the last thing that you do once you have all those key points put in your graph, then you decorate, then you add your data. It ensures again that you haven't missed anything. So that's what we kind of talked about yesterday. Today we are moving on into not creating a graph, but learning how to interpret a graph. So just a couple of quick things here. So one important skill is to be able to read, analyze, and interpret graphs. This is something that you are going to do probably your whole life, no matter what career job you have. At some point in your life, you'll need to be able to understand what graphs are telling you. And it's one thing I know that you get tested on a lot when it comes to standardized tests. Again, graphs are used to show patterns, relationships, and trends. And again, we use them a lot of times when we have a large amount of data. So again, sometimes we can figure out patterns and trends and relationships with just a data table. But when we have a lot of data, sometimes that's too overwhelming to identify those things. So that's what a graph is used for. So kind of have these three main steps for interpreting a graph. So let's say you have a graph and you're looking at it. There's three kind of steps that we like to go by. First step is to read the title. A title on a graph should tell you what the data is about. Now, I'm not going to lie to you, not all graphs do this. A lot of times they are way more simple than what they really should be. But hopefully when you read a title, it should give you information about the experiment or what the data is about. Second step is to look at both the X and Y axis. Again, those should be labeled and they should inform you what was being changed or what the independent variable was and what the dependent variable was, or what was being counted or measured in the experiment or in the whatever is being tested or whatever was being tested. And then the third step, once you kind of figure out what the graph is all about, then you start making some observations about the actual data. So what do you notice? What patterns do you see? Are there areas, maybe bars or lines or dots or data points that are higher in some areas of the graph or lower in some areas? So that's the kind of three-step thing that you should go through when you start looking at a graph. So we're going to kind of do that now. We're going to look at a couple graphs and practice this. One thing that I kind of find fascinating is how much pets love laser pointers. I don't know if you have a pet at home. Actually, I know a lot of you do because I've been watching them in the Google Meet. But we're going to just watch this little clip and then it'll make sense once we keep going. So here we go. Pay attention. We're not going to watch the whole thing, just a little bit of this clip here. And I'm going to mute this because I don't know if there's inappropriate words being thrown about, but you can see here that when we watch this little video clip here, clearly dogs are kind of crazy, and cats too, about laser pointers, right? This one like throws its body at the light, at the laser. So something's going on here with dogs, pets, and laser pointers. That one's super cute. He uses his paw. Okay, so let's say we are making some observations and we want to try to figure out a little bit more about dogs, pets, and laser pointers. Okay, So let's say we're watching this and we're interested in this. That guy's cute. And we do some research. So we watch that and we think, I want to figure out what's the deal with animals and laser pointers. And so we're doing research, and let's say we come across this graph. Okay, what are we going to do? What steps are we going to take to interpret this graph? Again, let's start with these 3 steps. Read the title, look at the axes, and then start making observations of the data, patterns, trends, areas of high and areas of low. So when I look at this graph, let's first read the title. It says, does the color of the laser affect how fast my dog runs? So that's what's going on in this experiment. We've got color of laser affecting the speed of the dog. Second step, it says look at the X and Y axes. So it looks like they tested 4 different color lasers or laser pointers on their dog. So we've got color of the laser, purple, pink, blue, and green. And their dependent variable, what they measured, again, is going to be on the Y-axis, and they measured the speed of the dog in miles per hour. Okay, so good information. Again, the third step is to start making some observations. So I observe when I look at this graph, and you probably should too, when I look at this graph, first off, I notice it's a bar graph. My bars are blue, but I observe right away that the green laser has the highest speed of 20 miles per hour. I also observe that purple and pink have the same speed of, is that 10 maybe miles per hour? I also observe that blue is the lowest. So again, what does this mean? When we put all of those little pieces, those little observations together, what does this mean? In my brain, my kind of overall conclusion is that green lasers cause the dog to run faster than the other colors, specifically in this test. Now, I know as a scientist that I should not base all of my, I shouldn't put all my eggs in one basket, that green cause all dogs to run the fastest. Because again, this is just one person's test. So I might want to try to see if there's maybe some other data out there. And to be honest, I just completely made this graph up. So I don't know if green actually does cause dogs to run the fastest. But according to this lovely graph, that's what it says. All right, we're going to look at another graph and do the exact same thing. Here we go. So here's our graph. Take a look at it. Again, we're going to answer those 3 questions, or go through those 3 steps: titles, labels, so we know our variables, and then what does the data show? So I want you to think about this. I'm going to give you some awkward pause right now to look at this graph and read what it's telling you. Do that right now, please. All right. So, step 1, once again, is to read the title. Title says, and I apologize if it's kind of small, it says, does the time spent in quarantine affect the number of pets people own in Anoka County? So it's telling us about time in quarantine, and it's telling us about pets in a specific location. Okay, so that's a good title. It's very informative. I'm going to look at the X and Y axis. It has months of 2020 down here, so January through November, 'cause it's not December yet. And my Y axis is number of pets owned in 2020. So I'm guessing this is the average, it says, in Anoka County. So that gives me a lot of information about what this graph is about. Now we make some observations. So a couple things. And hopefully you made some. I observe, first of all, that this line is trending upward. I see that it went from 1 pet to the highest point, which is 5. So overall, it's increasing. Even though we got a little dip here, it's still increasing. I observed that the lowest that it was at 1. I also would say that it's the highest in October and November. I could also say right here that it was that there was a decline, or it decreased from July to August. Okay. One thing that you also have to be able to do is a lot of times answer questions about a graph. So I might say something like this. What was the number of pets, the average number of pets owned in July? And how you do this is we would find July on our x-axis. We would go up to the little data point here, and then we want to follow it over to the number. Okay, so again, starting on the x-axis, finding July, going up, and then over to get to our number. So what this tells us again is that in July, the average number of pets was 4. Another thing that sometimes questions or teachers or questions that you'll have about a graph is predictions or inferences. So what you think may have been the reason for maybe a reason for it to go down or for maybe it to generally increase. You could say something like, well, in January, people were able to be around people and people were able to go out. In this area here, when we were in quarantine, people kind of got lonely. And so the increase maybe was due to loneliness. Is that perfectly clear on the graph? No, that's an inference. That's kind of what you could possibly a reason for the results that you're seeing. Same thing here. In July, if you remember, kind of in June and July, we started being able to go out and the quarantine was lifted. And a lot of people, unfortunately, that had purchased pets, I heard this from, Humane Society websites and whatnot. There were getting a lot of people that were returning pets because quarantine was over and they didn't realize that, having a dog was so much work. And so I heard a lot about that. So I could possibly make the inference that in July, people were returning their pets that they bought. Okay. Again, do I know that for sure based on the data? No. But again, I could infer that could be a cause of that decline. So again, you need to be able to not only figure out what's going on in the graph, but you need to be able to answer questions referring to the data and then making maybe some predictions or some inferences about what the reason is for your data to be that way. All right, we got a couple more. Here we go. This graph is a little bit more complicated. So this is called a double line graph. So we've got the blue line and a red line, okay? So something big is going on here. So once again, we are going to, and we'll get back to this graph, but once again, we got to read the title. We got to figure out what's going on in the graph. What's question was being investigated. We're going to look at the labels, the X and Y. They're going to tell us some information, and we're going to start making some observations for patterns, trends. So it says rotifers and zebra mussels in the Hudson River. And if you don't know what a rotifer is, you're probably not alone. It is this little guy here. It is I think it's a protist, or maybe it's a small crustacean. I don't know, but it's a little tiny thing that lives in water. And very small, very microscopic. I think it's unicellular. And then zebra mussels. If you're like, what the heck is a zebra mussel? This right here is a zebra mussel. It's a type of mussel, which is like a clam kind of looking thing. And they actually are an invasive species. What that means is they were not originally found here, and they're kind of messing up the habitat and the ecosystem that they live in. So what we know, again, this isn't in this graph, but I know that zebra mussels they're filter feeders. So they filter their food from the water, which means that these guys here are eating these guys here. Okay, so these guys, the zebra mussels, are the predators, and these rotifers are the prey. Okay, now again, you might not know that by looking at this graph. You might have to do a little bit of research, but that's what I've got for you there. So we've got the title down here. We've got year, so it goes from 1987 to 2009. And then here we've got ZM, or zebra mussel density. So that's basically how many zebra mussels are in a certain space of land or space of water. And then we've also got that over here. We've got about the rotifer population density too. So lots going on in this graph. What I notice now, so again, once we've got that down, we're going to start making some observations. One thing that I immediately notice is there's lots of these things going on. There's ups, there's dramatic increases and dramatic decreases, increases and decreases. Now, looking at this graph, you might not be able to know exactly what the reason is for the increase and decrease, right? But what you should at least be able to do is answer some questions about the data. So for example, if I were to ask you, What is the zebra mussel, or about the zebra mussel density in 2007? Okay, I'm going to say that again. Think in your head. What is the zebra mussel density, according to this graph, in 2007? Okay, think about it, think about it, think about it. Zebra mussel density in 2007. What is that? First thing you should do is find 2007, which is right here. My cursor was kind of on it. Then I'm going to go up and find my zebra mussel point, which is right here. Then I'm going to go over as straight as I can to right about here. Now there's not a number, a perfect number right here. So I'm going to kind of have to estimate a little bit that my number is between 3,500 and 4,000. So I'm going to kind of have to guess on this one. I might say zebra mussel density is about 3,750 or, 3,700. Because again, I don't have a perfect number here, but I know a little bit or about halfway between these two numbers. Okay. Same thing. I might ask you, what is the rotifer density in 1992? Again, look at the graph. What is the rotifer density in 1992? Okay, so let's look. Again, 1992. Rotifer is the blue line with the little triangles. So I'm going to go up, 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 up until I hit the mark right here. And then again, I'm going to go up. I'm not going to go this way. This is tricky. I'm going to go this side here because this is my rotifer data here. So I'm going to say it's a little less than 400. So maybe like 380 or something like that. Again, I wouldn't say every single double line graph has stuff over here, but sometimes they do. Okay. The other thing that I would say too is there might be a question like, what happens to in 1997 or 1997? What happens to, or what is the rotifer population when the zebra mussel population is a little above 3,000? So again, if I look here, the zebra mussel population is way up here. I noticed that, when those things are high, the rotifer population is kind of low. Okay, so again, it's picking out little bits of data from the graph, but also noticing trends and patterns. When, the rotifers are really high, zebra mussels are really low. When zebra mussels are higher, rotifers are kind of low. So there's kind of that opposite effect that they have. This is a tough graph though. If you're not following me, that's okay. Let's do one more and then we're done for today. Last graph. So we are looking here at monarchs. So we're looking at butterflies. This is, again, I want to do this. Read the title, axes, make some observations. So it says, Western monarchs are rapidly declining. This is showing us the population of the Western monarch butterfly between 1997 and 2019. So we're looking at monarch population. So how many monarchs are around in a certain time period, which again is why it's a line graph. So looking at my labels, I've got years down here, and I've got estimated monarch population here. Immediately, I notice that what's happening to this line? What are you noticing? It's going down a lot. It has gone down significantly in that time period. That's the first thing that I notice. It went from, and it gives us a nice little data set right here. It went from like 1.2 million to like a little under 30,000. That's a pretty dramatic decline. Another thing I would say that I notice is it's been consistently low since about 1999. So something really bad happened right here to these poor little butterflies. We don't know what that is. Could it be pesticides? Could it be a harsh winter that killed a bunch? Could be. Graph doesn't tell us. Another thing we could look at with the graph is that something might have happened right here. There was a big decline again in 2017. A question that you might get asked with this graph is what was the population of monarchs in 2015, which you find 2015 and you go up and over, which is 300,000. Another question, according to this graph, could be at what years was the population of monarchs 300,000? Again, I'm going to say that again. In what years was the population 300,000 butterflies? Where you would have to look and say, okay, in 1909 it was at 300,000. 2015 it was at 300,000, and even maybe right here, which was 2016, it was at 300,000. So yeah. All right, guys. Well, again, just to kind of reiterate, when we are looking at graphs, first and foremost, first step, read the title. It should be informative. Sometimes they're not, but it should have some information that could give us about what's going on with the data. Again, look at the different axes, read what those are to give you more information. And then again, what do you immediately notice about the data? Is it increasing? Is it decreasing? Is it kind of going back and forth? Do you see patterns, trends? And then again, paying a close attention if you do have to answer questions. Finding that number on the x-axis and then going up and then finding that on the y-axis. Okay. All right. That's all for today. I hope you have a great weekend. And on Monday, you will be doing some interpreting of your own. All right. So we'll see you later, everybody.